Mechanism of intrinsic pathway. Injury to blood vessel or surface contact of blood alters factor 12 which is converted into 12A. The 12A convert inactive factor 11 to 11A. The activated factor 11A activates factor 9 to 9A. The activated factor 9A activates the factor 8 to 8A. The activated factor 8A now converts inactive factor 10 to 10A, that is the active 10. The factor 10A or active 10 then interacts with cofactor 5A or active 5, then calcium ion phospholipids to form prothrombin activator. In this in this factor 5A acts as a cofactor. Next is the extrinsic pathway, which starts by the tissue trauma or tissue damage, which releases the tissue thromboplastin, that is factor 3, and the protein glycoprotein phospholipid. In presence of the tissue thromboplastin, it acts on a factor 7 and this factor 7 gets activated. This factor 7 then activates the inactive factor 10 and it gets activated factor 10. And this activated factor 10 and this factor 5, that is the active factor 5, in presence of the calcium ion and the phospholipid, it forms a prothrombin activator. This is regarding the extrinsic pathway. Then this extrinsic pathway requires contact with tissue factors external to blood. This occurs when there is a trauma to the vascular wall and surrounding tissue. The extrinsic system is triggered by the release of tissue factor thromboplastin from the damaged tissue that activates the factor 7. And the tissue thromboplastin and factor 7 activates the factor 10 into 10A. In this figure, extrinsic system, this is the tissue thromboplastin which is acting on the what? This inactive factor 7 and it makes the factor 7 active, that is 7A. In presence of the calcium ion, phospholipids and the tissue thromboplastin, it activates the inactive factor 10 into the 10A. In presence of the factor 3, that is from the tissue damage, that is tissue thromboplastin, factor 7, which is an inactive one, it becomes an active one, that is 7A. Calcium ion and the factor 10 is converted into the 10A. The factor 10A then interacts with active 5, then calcium ion, phospholipids to form prothrombin activator as in the intrinsic pathway. This is regarding the how there is a formation of the prothrombin activator in both extrinsic and intrinsic pathway. Then stage 2 and stage 3, these both are similar for the extrinsic and intrinsic mechanism. The stage 2 is conversion of prothrombin factor 2 into thrombin, that is factor 2A. The prothrombin activator converts prothrombin into thrombin in the presence of calcium. Thrombin itself can accelerate this reaction by positive feedback mechanism, that is, the initial thrombin activates factor 5 into 5A. This in turn accelerates the formation of both extrinsic and intrinsic prothrombin activator. This is the factor 10 which is activated into the 10A. Then the factor 5, then calcium ion, factor 5A, and these are the phospholipids. These combine together to form the what? The activated, it is combined together to form the prothrombin activator in the extrinsic as well as the what? Intrinsic pathway. So this will form the prothrombin activator, and this prothrombin activator will now act on the prothrombin, that is factor 2, and it will convert this prothrombin into the thrombin. Then that is the prothrombin activator is formed by joining this 10th A, then 5A phospholipid and calcium, and this forms the prothrombin activator, and this prothrombin activator acts on the factor 2, that is a prothrombin, and it forms the factor 2A, that is the thrombin molecule. Then the stage 3 is the conversion of fibrinogen, that is factor 1 into fibrin, that is a factor 1A monomer. During this, the soluble fibrinogen is converted into insoluble fibrin by the thrombin. Initially, the fibrinogen is converted into activated fibrinogen, which is called as a fibrin monomer. And this polymerizes with other monomer molecules to form the fibrin. The first form fibrin contains loosely arranged strand, and this is modified later into dense tight aggregate fibrin stabilizing factor, that is factor 13, and this reaction requires the presence of calcium ion. This fibrinogen or factor 1 in presence of the thrombin, it becomes activated, that is activated fibrinogen, that is factor A. And this activated fibrinogen, this is a monomer. This after polymerization, it forms a loose strands of the fibrin. And uh, these fibrin or the loose strands of the fibrin in presence of this factor 13 and the calcium ion, it forms a tight clot or the fibrin tight clot. So this is the figure from where the what this is the prothrombin activator formed by the TNA, phospholipids, calcium ion, and this factor 5A. It this forms the prothrombin activator, and this prothrombin activator is going to activate this prothrombin or the factor 2 into the 2A, that is a thrombin, and this 2A, that is a what thrombin, it will activate the factor inactive factor 1, that is a fibrinogen, and this inactive fibrinogen is activated to form the fibrin monomer. Means this 2A, it acts on the one inactive one, and it forms a activated one, that is the fibrin, and these fibrin monomers, they combine together or they polymerizes in presence of the what destabilizing factor, that is a 13, into the what, that is a 13A, and it stabilizes the fibrin molecule, and it forms a tight clot. So these are the what the blood coagulation or the mechanisms of the blood coagulation, and this is the fast extrinsic clotting system and intrinsic system. That is a what are the difference between these the two? The second and the third that steps are similar. In this what extrinsic clotting mechanism, this factor 3 or the tissue thromboplastin and the what factor 7 and the factor 4, that is a calcium ion, that are utilized, and after that when this factor 7 is activated, it acts on the factor 10 and it activates the factor 10A, and after this factor 5 is activated into 5A, then calcium ion and the phospholipid, these whole, that is 10A, 5A, calcium ion and the phospholipid, they combine together or join together to form the prothrombin activator molecule. Okay. Then in intrinsic clotting mechanism, it starts from the factor 12. It activates it get activated and it becomes 12A. This 12A activates the factor inactive factor 11 to form the 11A. Then 11A, it acts on a factor 9, which is a inactive in presence of calcium ion, and it causes the and it becomes a 9A. Then 9A, it acts on the factor 8 and it activates the factor 8 into factor 8A. Factor 8A in presence of the calcium ion and the phospholipid, it acts on the factor 10 and it causes it activates the factor 10, and this 10A, then factor 5A, calcium ion and the phospholipid. These causes the formation of the what the prothrombin activator. And this is the first step, how the what extrinsic and intrinsic mechanism are differing. Then the second step, that is a conversion of prothrombin into the thrombin. That is prothrombin is a inactive. This is a inactive factor 2, and this inactive factor 2, it is activated by the prothrombin activator, and this prothrombin activator converts this prothrombin which is a inactive 2 into the what the active 2, that is 2A, that is a thrombin. And this thrombin molecule in presence of the calcium ion, and it activates the 13A, that is stabilizing factor, into 13A, and this thrombin it converts the what the convert the fibrinogen which is a inactive one, inactive, that is a factor 1 into the active factor 1, that is a fibrin monomer, and this fibrin monomer, then fibrin monomer gets converted into the fibrin polymers, and these fibrin polymer, then it fibrin fragments are formed, and they form the tight clot. Plasmin reaction occurs in presence of the plasminogen and the antiplasmin. There is a dissolution of the clot, so or the fibrolysis of the clot. So this is the mechanism how there is a blood coagulation or the blood clotting.